Welcome, everyone. Thank you for coming this morning at such an early hour. Thank you for watching from home and joining us from home. Today we're going to talk about something that we as Open Science SIG like a lot, which is open science. We're going to have a symposium titled Off the Beaten PI Track. We had to change a little bit last minute the order of our speakers because unluckily we plan to have 3 speakers on site and 1 online, but unluckily one of the speakers on site cannot come today. So we're going to have in order Cassandra Goldman-Prague, Priya Suppiah, Benjamin Delanier, and then we're going to hear about Steph Noble. We are going to collect questions both from the audience online and from the audience here in person through the app or through the website. If you want to ask questions, just go on the app. There's a section to ask questions. We're going to, Johanna and me are going to monitor it for purposes of asking to our speakers. And otherwise, if you don't have the app, you can go on the website ohbm.cnf.io. For the rest, we're going to have a couple of minutes after every speaker to ask a couple of questions, and then we're going to have a longer question and answer moment at the end of this presentation and at the end of this symposium. And this said, I'm going to just start presenting our speakers and introduce the first one. The first one is Cassandra Goldman-Prague. She works to generate opportunities for the research community to actively participate in and contribute to open science infrastructure at the Wellcome Center for Integrative Neuroimaging at the University of Oxford. She also works between departments and alongside partners in other institutions to develop policies of recommendations for good governance around open science that works for individual facilities across departmental boundaries with medical sciences and beyond into the wider university and national networks. If she didn't join academia and became an academic, she would have run for circus. So I guess this is the perfect person to start with our open science symposia. Cassandra, the floor is yours.
Hello, good morning, everybody. So, as you can see, I've got subtitles. So the subtitles are for the benefit of anyone who doesn't speak English as a first language and anyone that is hard of hearing. So sometimes they get a bit freaky, but you know, if funny words come up, you can laugh and I'll laugh with you. So thank you for coming in so bright and early. Thank you for not getting COVID yet. This presentation is designed to give you an idea about new ways of working in academia and opportunities that are presented by the complexities of open science. So unfortunately, as many of us will be aware, the probability of a PhD student getting a professor position, a tenure track position, is about 4% of all students will get to that stage. And as a result, many of us will end our academic careers feeling like we've failed because we haven't reached that all-hallowed position of a professor or a PI. Now, this unfortunately breeds an unhealthy competition between us, and it can lead to burnout and also precarity. And all these things contribute to bad research practice. So I'd like to tell you today about the new opportunities for job roles and career paths that focus on supporting our researchers to deliver open science. So before I go any further, I'd like to put up front some people that have supported me in my career so far, and also some people who have contributed to the ideas presented in this presentation. So thank you all to these folks. So our research is complex. We all know this. But with the increasing awareness around issues of open science and robust research, there is new focus on specific parts of the research practice, which, as many students coming into academia, they don't yet have the skills to address these complexities or to work with them. So, for example, in designing your research projects, there's going to be increased awareness and increased attention on doing things like pre-registration and registered reports. When you're collecting your data, there's more awareness around the importance of governance and good data management, research management. And our statistics are also increasingly complex, and there's more awareness around analysis that is robust to perturbations. And also code. So many of us write code, some people don't, and the practice around open science encourages sharing of code, so it's really important that code is well documented. Now, as I said, it might be unrealistic to expect the average PhD student to do all these things to a very high level, and this is where people who work in team infrastructure roles can be really valuable to help meet the complexity of these needs. And a framework which I think is useful in understanding this complexity is like a project management framework tool, which says that every project that we do has 3 constraints around money, time, and quality. And the idea is that you can never have all 3 of these things at any one time. You can only have 2 things, and you'll always be compromising in the middle. So, for example, if you want something done quickly and at low cost, you will sacrifice quality. And this is what happens when unskilled people or less skilled or less experienced people attempt things like research data management. If you want something done quickly and to a high quality, it's going to be expensive. So if you want excellent code, you can hire a consultant, but they are not cheap and they're going to make a big dent in your budget. If, however, you want something low cost but high quality, it's going to be slow, so you're going to sacrifice on time. And this is where volunteers fit in, I think, because unfortunately they can never prioritize the work of your project over and above what they're paid to do. And I think people in team infrastructure roles fit in that sweet spot in the middle. We can help you deliver quickly, with value for money, and at high quality. And the way we do that is because we bring our skills to your project fully fledged. So we don't have to learn things around research data management. We've spent our entire careers to this point working up to the skills that we have. So we can be quickly brought into your project and help you achieve what you need to do. We also give you value for money because we're often not attached to a specific project. We come from centre funding, so you don't have to worry about whether you have the budget to employ a research data manager or a software engineer. We're already available to you. And we can also give you quality products. As I said, our expertise have been developed over our entire careers, and that means that we can help your students and your postdocs deliver quality products around research data management, software, etc. So I think people in team infrastructure roles are incredibly valuable, but it's difficult to measure and track our contributions with the standard academic practices. You often won't see us on papers, and that's an issue that I'll go on to talk about soon. So now hopefully you agree with me that people in team infrastructure roles are incredibly important, and maybe you'd like to work with some of us. So I'd like to introduce you to a few friends and colleagues to give you an idea of the breadth of the kind of roles that are out there. So I'm not going to name all of these people, but these are real people and they're real good people. But I'll tell you what their jobs are. So we've got reproducibility trainers, reproducibility librarians, data stewards, research data and software engineers, licensing and IP specialists, and also people that work in liaison between translational clinical work and policy. And open science is also about collaboration. So there's a set of roles that are specifically designed to facilitate collaboration and big research groups. So we've got scientific managers, project managers, experimental support, alliance officers, program managers, and managers of data managers, and community managers like me. So all of these people, not only are they really nice, they, I think I can speak for all of us when I can say that none of us ever saw ourselves in the position of PIs. None of us ever wanted to be PIs. We wanted to help people, and we enjoyed that, but without the development of these kinds of roles that we do, there's no route for us to continue to contribute to academia and bring our skills and passion and enthusiasm to the work that you do and the work that we do. So to give you a bit more of context about how people get into these kinds of roles at the moment, this is my journey in a kind of graphical illustration of the ups and downs of academia. So I started my PhD in 2009 and I submitted in 2013. And I did it with like the normal amount of stress, like nothing too horrific, but also probably not the best, which I think is very normal. And then in my postdocs, I was really reinvigorated and excited about the practice of doing science. So in the transition from PhD to postdoc, I found myself working with other people again, and that was super exciting for me. I was doing things like sharing my code just within our lab, and it was just felt really wonderful to be able to help other people do the work and also train and mentor people as well. But about this time, I can remember explicitly someone saying to me, be careful or you might become a technician. And I remember feeling like surprised and shocked and also disappointed. I was like, what's wrong with being a technician? I could be a really good technician. Why would that be seen as a failure if I became just a technician? So in 2018, I moved into my first, what I now see as an infrastructure role. It wasn't labeled as that at the time. And there, my role was explicitly to help other people. I wasn't attached to a single project, but I was training in image analysis across a large research group. And again, I was returned to that point of helping other people. And I also really enjoyed not having to like focus on that one brain area. Some people like their one brain area, but and shortly after that, I found the Open Science Room OHBM, and from that point, my passion for the work that we do as researchers has just skyrocketed to the point where I was enthusiastically training our lab to do open science practices, and then offered the opportunity to do that across the whole imaging center. So that's my role now, is I train in open science, I encourage people to engage with it, and I also work to develop policy and practices and infrastructure which work for the researchers. So not only am I helping people do open science in like a practical skills way, I'm also helping them do it by developing systems that actually they can apply. So my career, I think, is continuing to go upwards. There's some really exciting opportunities coming around the corner. But as the graph indicates, I have never been as happy as I am now doing the work that I do. But an important consideration in my own career trajectory and those of all my friends that I showed on the slides comes down to how we're classified or qualified by the university systems that we work in. So the question is, are we researchers? Are we contributing to the body of knowledge? And I think there's an interesting distinction between the type of roles that we're in, where we do contribute to the content of the research, whereas other roles, for example, like HR, administrators, finances, they facilitate the process of research, but they don't have so much input in the content. We actually help design and improve the actual things that go into the research. But this distinction between whether we're researchers or professional services really matters to people like HR, because at the moment, they don't recognize us as researchers, so there's no career path for our development. We're not going to be PIs, so they really don't know how to handle us. We're also as skilled as like normal researchers, but the career tracks for people in professional services don't really take that into account, and there's no opportunities for progression for us. So this is an issue for people like me and people that you might like to work with like me, that there's unsolved problems around reward and recognition for the work that we do. So I've got some recommendations for what I would like to see. And the first of those is that if you are expecting people to do this work to the high quality that you would like, I really think these people should be paid. So of course you can have volunteer data stewards and volunteer software engineers, But in order to really hone our skills and deliver the best we can for you, we need to be able to prioritize this work, and that means we need to be paid for it as our primary role. We need to think about career progression. So as I said, there's not really a defined pathway for our careers to, like, assistant professor, whatever comes next. That doesn't exist for us. And without a defined pathway to development, we're going to stagnate and we're going to leave. And none of us want to do that. We want to stay in academia. We also need to think about how people in these roles can be given credit for the work that we do. And credit, with this kind of capitalization, I mean the contributor role taxonomy, which you may have heard about in some journals asking for it. And this means you explicitly identify the different contributions that have been the different contributions of people to your research outputs. And by the practice of open science, your research outputs aren't only papers, they can also be things like data sets and code. So it's, I think, a really good opportunity for us to be recognized for our work is that people like data stewards should get cited on your data papers. And if you do things like DOI and license your data and use the contributor roles taxonomy, there's an easy way for us to be recognized for our contributions, even if we don't belong on your main papers, your the paper that's about your actual research. And I don't have the answer for this, but if you do value and want to recognize and reward people in these roles, we need to think about ways to celebrate these contributions. So it's not abnormal to see on Twitter, for example, such and such rising star has been awarded this amazing thing, their career is going to be wonderful. Those kinds of competitive awarding processes don't exist for people in these infrastructure roles. So they are, at the moment, never going to get to stand out as someone who has achieved excellence in their work. So I don't know, these competitions and prizes can be weird and bad in ways, but I really think there's something we should be thinking about is how we celebrate the contributions of these people, because without feeling celebrated, they're going to feel undervalued. So if you want to work with these people and get your projects to be these super open science amazing things with wonderful data and pre-registered reports and things like this, I really think we need to think about how we resource people in these roles and how we invest in them. So by resources, I don't only mean the physical things or the compute cluster, it's about people as well. So many people and people on the stage and other open scientists I know, we're incredibly skilled across a broad range of open science practices, but we can't do everything by ourselves. Recognize that the more people you put into this problem, the easier it's going to be for your researchers to do the excellent work that you're looking for. And along with resources, we need to invest. And investment, I don't mean only in developing more resources, but also invest in the careers of these people, help them progress, help them feel valued, and help them stay in academia. Thank you. Last slide. So this is my last slide. So to sum up all of this, these are the things that I think are important around team infrastructure roles and the gaps that I think we need to think about. So team infrastructure roles exist because there is increasing complexity in the work we do, and there's special skills or specialized skills that we can bring to your work, which you can't expect your standard PhD students or postdocs to have already because the training just isn't there at the moment. We are incredibly valuable, I think. We can give you high quality and rapid value. We can give you high quality and rapid outputs with low project costs. So who doesn't want those kinds of skills in their teams? We all really, really love teamwork. I think that's a key part about the people in these roles. We like to work with other people. So if you'd like to work with us, I encourage you to actively collaborate and early on and throughout your whole project. We need to think about how we reward people in these roles. How do we show that they are valued and valuable? How do we recognize their contributions? Where do we give them credit? and how do we resource them going forwards. So that's it. This is my opportunity to highlight that there are other things that you can be in your career other than a PI. And if that's something that's interesting to you, I'm here, many of us are here. I don't want anyone to feel like if they're not a PI, then they have failed. It's okay just to be a technician. Thank you. So questions?
Yeah, thank you, Kaz. That was awesome. So we are going to probably have time for 2 questions. And one of the most voted questions here is, if I don't want to play the game of publish or perish, how can I promote recognition of open science works like TRIs in my faculty?
Unfortunately, publications are the currency of academia at the moment. But you can, as I said, create other outputs that aren't papers. So I put out tons of educational material, and I tag the people that have contributed to it, the researchers. And data sets are like hard to create, but you can release them in a way that gives credit for the people that contributed to them, and code as well. So actually, I think documentation and training materials is one of the easiest ways to acknowledge the contributions of other people. And they are easier to put out than papers. They're quicker and maybe more useful sometimes.
Great. Another question is, how do we approach finding TIRs in cases where they are non-explicitly established? Can TIRs potentially emerge from postdoc positions?
Yeah, absolutely. You have to be in a place where people are familiar with the practice of having like core staff or research scientists and things. So I think it's difficult to get to that point from nothing. But it's not impossible. You know, we didn't exist always, and there's things like data champions, which there are tools online that talk about how to create these roles. So I think there's a political bit of work to do to speak with your like employers, say like, oh, wouldn't it be great if I had a data steward? And then it's going to be a slow burn, but we like these roles existing, so there are materials online that you can draw on to help create them. And also, you can talk to me.
Excellent. Then let's thank Cass once again.
Thank you.
The next presenter up is Priya Suppiah. And we should have a video from her? Perfect, thank you very much. Priya Suppiah is a dual-trained nuclear medicine physician and a radiologist working at University Putra, Malaysia. She is also a senior medical lecturer at OHBM, and she is the head of the nuclear imaging department at her institutional teaching hospital. She is currently the vice president for the nuclear medicine wing of the College of Radiology, Academy of Medicine, Malaysia, which is the National Radiology Society in Malaysia. She is also a council member for the Malaysian Society of Nuclear Medicine and Molecular Imaging and head of the research subgroup of the society. Her keen interest in brain imaging has led her to be the founder of the Malaysian Society of Neurocognitive, Clinical and Behavioral Imaging, known as NeuroCoB Society for short. Along with her postgraduate students, she conducts research and various educational events under NeuroCoB Society and Lab that are related to her research interest, which is imaging of behavioral addictions and Alzheimer's disease diagnostic. We have a video from Priya, and if it's ready, I'll let you play for it. Priya is not with us today in the room, but you can ask questions on the app. And Priya, if she's watching us, please answer those questions in the app, and we're going to read them.
Hi everyone, I'm Subapriya Suppiah from University Putra, Malaysia. I am an academician, a radiologist, nuclear medicine physician, and scientist. Together with my postgraduate students, I conduct research related to behavioral addictions and Alzheimer's disease using neuroimaging technology in our lab called NeuroCop. For those in academia, the phrase publish or perish is often heard and is a source of anxiety and stress. But I prefer to live by the mantra, publish and flourish. To understand how research impacts our life in a positive way, we first need to understand that historically, research was conducted in closed laboratories, in universities lauded over by senior professors and only disseminated to learned scientific community that were comprised of experts in a particular field. In order to access and read scientific articles in journals, conventional publishing companies will charge a subscription fee that may cost thousands of dollars to the general public. This makes it difficult to access information, especially for researchers in countries with limited financial resources. Furthermore, career development and promotion in academia was heavily dependent on the quality and quantity of published works by the researcher. So how can we overcome these challenges? For a start, researchers need to be empowered to share their research using an open science approach. Publishing in open access journals means you only pay once and you make your research perpetually available to everyone without incurring more expenses to them. Additionally, by sharing data in open source repositories, other researchers can benefit from a larger pool of data without putting more strain onto their already limited resources. Big data made publicly available also facilitates advancements in radiomics and development of softwares utilizing artificial intelligence to improve diagnostic services in the healthcare system. To me, open science involves 4 R's and 2 C's, whereby the data should be reliable, reproducible, reusable, and relevant, as well as involves community collaboration and be cost-effective. From my experience in international neuroimaging research, my students and I have published in neuroimaging international open access journals, and we have also published our study protocols. By making our research transparent, we can share our work, and our work becomes reliable and are referenced by researchers worldwide. By utilizing tested algorithms and sharing our data set openly, we can facilitate our research to be reproducible. Our research has also become reusable and relevant, particularly with the advent of the COVID-19 pandemic and the huge strain with the use of global internet. Social media addiction has taken its toll in many lives. This has made our publication on Instagram addiction very relevant. In fact, a German publishing company doing investigative reporting interviewed our research team. Our work has gained international interest, and as a result, students are feeling recognized and can get better visibility for their research and can advance their own careers. Practicing open science fosters better relationships between researchers and MDs, which can translate into meaningful and impactful clinical practices. Researchers have the tech know-how, whereas MDs have the clinical background to share their insights on disease pathophysiology and what is needed to diagnose or treat a certain disease or disorder. Particularly, my research involves improving the diagnostic accuracy for detecting Alzheimer's disease. I work closely with a diverse multidisciplinary team comprising of psychiatrists, psychologists, geriatricians, medical physicists, engineers, and computer scientists. Instead of competing with one another, we work as a collaborative team, and this strengthens networking within the scientific community in general. In a nutshell, encouraging reproducibility of data and depositing data in open source repositories, as well as supporting open access publication platforms, helps open up opportunities for gaining recognition and also career advancement in academia. And that's why I say open science opens doors. Thank you.
We are going to have a couple of minutes just to make questions roll in and for Priya to answer. And if there are none, we can pass to the next speaker.
Yeah, so hello also from me. It is my great pleasure to introduce our next speaker, Benjamin Delina. Benjamin is an assistant professor at the Polytechnique Montreal, Canada, researcher at CHU Saint Justine Research Center, and holds a chair of the Transmed Tech Institute in Pediatric Neuroimaging. His research interests pertain to the development of open source software for analyzing brain and spinal cord images acquired with magnetic resonance imaging, using advanced segmentation and registration approaches, machine learning, and neurodevelopmental templates and atlases. And Benjamin actually also did what he would have done if he wasn't in academia. He founded his own company. Over to Benjamin.
Thank you very much. Oh, here it is. So it's really my great pleasure to be here talking about what I call the tipping point of my career. And I'm actually really lucky because I am a PI. And I was lucky to be a PI. And this question that I will show you after, it gave me the opportunity to be a PI. Joanna just said that if I was not going to be in this position, I would have started my own company. Well, that's really something that I considered, and I would have done differently if I was not given the opportunity to be in open science. So without waiting, here is the question that I got asked at the beginning of my career. Do you want to file a patent? It was a question asked by my co-supervisor at the time, Julien Cohen-Adat. And back in the days, I was studying my master degree, working on developing a method for automating the segmentation of the spinal cord. For those who don't know the spinal cord, what the spinal cord is, and I'm pretty sure you know, I hope so, is a structure within the spine that is quite important. 10 years ago, there was not a lot of methods that were available for segmenting the spinal cord, and those that were available were not completely automated. Then I need to do it. But they were also it was difficult to get access to them. Either they were not open source and you had to re-implement them, or well, it was difficult to install them and use them. And so I started working on my own method, which is called PropSeg. If you work in the spinal cord, you probably heard of it. And it worked great. I made it completely automated, and I got a validation study on 15 alpha subjects. It was actually high at the time for me. And I got accepted at a conference, SPIE. And my second abstract was at OHBM, actually. So I really love OHBM for that. I continued working on it, and we started working on a manuscript. And that's when Julien asked me the question. So with your technology, with what you have done on your approach, do you want to file a patent? And I responded immediately, no, of course not. Why would I do that? And my thoughts were, well, I struggled so much to find a method that was already available and that I could use. Why would I do that to someone else in research? And so obviously, it was like really obvious to me, I need to open source my method and make it available to other people. And so we did. We wrote some code, we put it on GitHub, and we packaged it in a software that's called the Spinal Cord Toolbox. And we wrote in the manuscript how program is freely available at that URL. It started my career in open science. It started with all the issues I had after that as well. The first commit was in 2014, and the first issue was a month later. And I started a PhD with Julian at Neuropoly right after that, just continue working on the software and adding more features to the Spark toolbox. Well, if you want to check it, it's over there. It's completely open. There is a lot of things that you can do with it. It's a group effort, it's just not me. There is a lot of people behind in maintaining it and adding new features. And that can include you as well, because it's open and you can contribute to it. But why is open software, and I'm talking about open software here, not necessarily all open science thing, why is it good for me and why could it be good for you? Well, you may smile if I tell you that the first reason why software developer release an open software is altruism. And it may sound weird in the industry, but it's not weird at all in academia and in research environments. We actually do things because we want to help others. So it makes sense to release a software in the open way. It brings a sense of value, it has personal benefits, but they also bring community recognition. Because your name is going to be associated with a software, people are going to recognize you as someone that has provided them a tool for helping them in their work. So it brings community recognition and self-advertising. It also improves the quality of the software. Well, it's quite simple. If you do a software for yourself, you do some code, you write some scripts to analyze brain data, and you keep it for yourself, it's probably going to be ugly, right? Well, that's fine. It's just for you. Maybe later you're going to tap yourself on the hand and say, why didn't I write proper codes? But that's fine. But if you want to put it online and don't want to feel guilty about that ugliness, well, you have to improve the quality of the code. You may be you may want to add documentation, tutorials, and tests so people don't get issues all the time. And it improves the quality of your software, so you get better software by being open. Of course, open software has side effects like miscommunication, misunderstandings, potential threat to the core business value. I'm going to come to that later. That's really important. Change of responsibilities. We talked about that just before. And funding as well. It has a lot of side effects, but I want to concentrate on the advantages first. And this is my story. There is a lot more, but I just want to give you some example of what it brought to me. So community recognition, we opened a forum where people could just say what they think about the software, bad things and good things. And if you cannot read the sentence here, it says, SCT made a breakthrough enabling the quantification of spinal cord MRI, blah, 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 blah. When we read that, it's really, we're really happy to read that. This is like the best recognition that we can have. We have an impact, just people telling us that our software brings value to someone else. And it shows when we look at the citation of our manuscript, because we wrote several manuscripts that represent the software, and when people use the software, we tell them, cite this. It's just not for citation, it's just for keeping track of what impact we have when we develop code. And I think that's really important to do that, because usually we write code to make research, to make a study, but you actually sometimes write codes for the code itself and to bring a tool for the community. And you need to keep track of how it's used. Citation is one example, down notes is another. There are many ways. And you can see here over the years how it's getting used and in what field it's getting used. And so it's really important to keep track of these because it helps you continue making the software work, because you have to maintain it. And it's important to keep the motivation on. I told you about self-advertising. It's a group effort, but your name is associated with a paper, and we made the comment here that number of citations is still a currency in a field. I hope it would not be, but for getting a PI position, you need citations. And in my case, it helped a lot, because I'm really into the development of software and development of methods for image processing. Well, if I don't get citation for that, I don't get citation at all. And so by just being open and making sure that people can use the software, I get citation, and I got my PI position probably for that as well. But what makes a good open software? Well, in our case, we felt that it was really important that people could use it really easily. And so we wrote a lot of wiki pages, like how to get started with examples. We made tutorials, but a lot of tutorials. It took a lot of time just for people not opening the page, downloading the software, and not knowing what to do with it. And so it's really important that people get started quickly, just so they don't move on to the next software in 5 minutes. We also organize a lot of courses, in-person courses, like at OHBM, at ASMM, just for people who would know us and we would get feedback directly. We also organize with the community challenges to improve the software. And it's not about the software itself necessarily, it's about improving the tools that we have for the research. But then we integrated the best tools that we had at the challenges into the Spark toolbox. And some other softwares that were developed at that challenge were not integrated into the Spark toolbox, and that's kind of competitors, but that's fine. Because then we have a bunch of methods. If our own doesn't work, well, we have alternatives. But that's what being open is, right? So you have alternatives as well. And of course, we open the software for contribution. And contribution here means feedback, issues, but also people that are working on something and then they just want to add it to the software. And so being open to contributing to the software itself, that's important as well. But it also takes a lot of time to manage that. We opened the forum where people could ask questions when they have trouble making the software work or just understanding how it works. And I was terrible at responding to these questions. And I was really lucky because I had someone in my team that really wanted to have this answer out quickly. And if you can't read it, I'm going to highlight it. The answers, this is a comment from one of the users, Ken, that says, well, SCT community quickly responds. And here it says communities, not necessarily us, which is a good thing, right? Typically within a day. And for me, that's insane. I'm not doing that. But it also gives you the sense of the rapidity, when you have a community, the rapidity of the answers that you can get when you're using a software. And that's also important because when you work on a project, you don't want to spend to wait 2 weeks to get an answer when you're using a software, right? Okay, this is all good, and I just told you that it takes time and resources, but it also has some side effects. And I mentioned miscommunication and misunderstanding. One example is that you will have many users, and some users are not software developers, some are doing research in a field, some are doing research in another field. And they may not understand completely why did you do this software and how to use it. And some user will say, oh, I want that feature, that's really important that you go into that direction, and you're like, oh, okay, I'm going to that direction, that's really fine, this is a neurosurgeon that told me that, and you're going to that direction, and then another one says, well, that was a mistake. I was like, okay, there is a misunderstanding there. I need to change things. And it's always about that, trying to satisfy the community, trying to understand what's the best way to develop a software. And it's complicated to see in all directions where you should go. So you need to be careful about that, and you need to deal with various type of user. I'm not talking about angry users that says, oh, your software doesn't work, you should do something else. That happens too. It's a threat to the core business value, and what I meant is if you do research, usually you want to do research for research, you're not doing software developments. But if you want to release a software and that the software is used for people, you have to do all the things that I just said. It takes time and resources. So are you still doing research, or are you doing software development? And it's really something that you need to be careful about when you're students, when you're PI, because it changes things in the lab that you're in. As a student, if you are doing research like me, developing a method and trying to validate it on the code, and then your PI says, well, now you're going to make sure that everyone can install it on Windows, Ubuntu, OS 6, and whatever is there, and then answer a question on the forum. I don't have time to do something else, so I'm changing responsibilities, and I don't like it. I just want to do research, and that was my example. And so I said to my PI, well, stop. you're going to do the things that you want to do. I'm going to do research. And I was lucky that I was able to do that, to say that to my PI. And as a PI, I need to be open about that for my students as well. But you need to be careful about the change of responsibilities when you try to be open and try to make sure that your software is being used by a lot of people. And funding, of course, I'm not going a lot into that, but if you want to hire a bunch of software developers or other people to maintain your software and then make sure that everything is fine, you need to find money for that. And it's usually not the same way as you do for PhD students, right? So a lot of side effects, but it's probably worth it. But should I file a patent? Patents, it's used to give control to the holder so that you know who's going to use it and you get money for it and then you control everything. While being open, the idea behind distributing software under open science license, well, you just release it and you see how it goes. You can still control how people are using it when they tell you, but it's open. Maybe they're going to be using it for creating a company and then making money. There are some licenses for avoiding that, but it's not really avoiding it. If you don't know about them, you'll never know. Did I miss an opportunity to make money? I don't think so. Because I got a good career and I'm in a good position. If I had a company working in the same software, I don't think I would have made more money. So I don't think that I missed an opportunity for my career. Did I make it easy for others to get published and famous? Well, if that's the case, that's even better for me. I'm really happy that other people got easier than I had when I was a PhD student. I think that's all about it. If you can help others, please do it. That's even better. So some take-home messages. Open science has many benefits. It also takes a lot of effort to make it properly. It has some side effects. Be aware of change of responsibilities, especially for the students. I feel it's really a discussion that we need to have. And great mentoring, and I'm talking to all the PI, great mentoring leads to great science. And I would like to thank my supervisor at the time, Julien Grenadat, for asking the right questions and for pushing for open science, because I was going into open science, but he embraced it as well. And so I think that's a strong move for him to embrace open science as well with his students and make sure that he was going into the same direction and pushing for it. So for that, I hope you enjoyed the presentation. I thank you all for your attention. And I'll leave the floor to Stefano. Oh, if you have any question, feel free to ask.
We have a couple of questions for you directly. So the first question is, how did you get funding resources to get a group to maintain your software?
I said I didn't want it to go into that direction, because it all depends on the country and the opportunities. There are fundings from, like foundation, for example, Mozilla Foundation, I think they do funding for maintaining open softwares, but your software needs to be big enough and used by the community usually for these type of grants. Probably the best way is to try to allocate some of the resources that you can get for grants, for example, as part of the maintaining an active community, maintaining an active software, and allocating this portion of resources for a research assistant, a research associate, or whatever you name them, that the funding agencies don't accept software developers. But usually it's getting more and more accepted as taking a portion of the grant that you would have for research for developing and maintaining an infrastructure for that research.
Thank you. Maybe another quick answer to a slightly provocative question. Do you think it is a privilege only for scientists with enough funding or resources to be able to publish open software? And if so, what can we do to make it better for people that do not have as many funding and resources?
I would say yes, that's quite a privilege to have the time to make it open and maintain. You can always make it open, right? You put your code on GitHub, you try to make the most of it, and I think that's worth the effort, just doing the best you can. And if you want to maintain a whole software, you need a team and you need funding, but it's a step-by-step progress, and don't feel discouraged by the funding aspects, because the community is also open for progress and to help you. And so I would say, if you don't get the funding directly, you won't get it probably directly, the funding to hire 2 software developers to create your software and make it open. You're probably going to do it yourself at the beginning. Well, involve the community to help you, and then your software will grow. It's going to be more open, and then you're probably eventually getting funding, because a lot of people in the community use it, and it's going to be easier to get funding.
Thank you very much. Thank you, Arjun.
So now it is my great pleasure to introduce our last speaker, Stephanie Noble. Stephanie can sadly not be with us. She was meant to, but she developed COVID overnight. Stephanie is a postdoctoral fellow in the Department of Radiology and Biomedical Imaging, focusing on statistical tools for more rigorous and reproducible human neuroscience research. Her research interests lie in the intersection of neuroimaging, statistics, and computational methods. And we should have a video from her. Okay.
Hi, I'm Stephanie Noble, and I'm going to talk about how you can make open science work for you as an early career researcher. So why might we do open science as an ECR? I think first and foremost, open science is known to be one of the foremost ways we can advance science. So this has been argued by many people. I think that there are many convincing examples out there. And I'm just showing you a few different of the ways that open science principles can advance science. Another reason to do open science as an early career researcher is that this can also advance your career. So I think that you can think of these two things as very complementary. A lot of people might think of these two things as at odds, and in some ways they can be, especially in the current scientific environment. But there are some ways where advancing your career, such as building your network or disseminating your work and making it easily understood, I think is very much complementary to advancing science. And because I think that the ways open science can advance science has been discussed so much in the past, here I'm going to focus on how it can advance your career as an ECR. So I'm going to focus right here on 4 topics. There are many others, but just for today, for the time, we're going to talk about 4. So why might you use open data and code? And by the way, for each of these topics, I'm going to talk about how, in my personal experience, this has had some benefit for me. So you might use open data and code because this saves you time, money, and effort. So this is a big one for me. For many of my projects, this cluster failure, power failure project, that was an empirical resampling project, and some of my other empirical benchmarking projects that I'm currently doing. I relied on the Human Connectome Project dataset, and I've worked with many others relying on many other different types of openly available datasets. And that saved us a lot of time getting started, and money, and of course effort acquiring the subjects. You also learn a lot of transferable skills. So working with these large open datasets often require us to use many different types of platforms to analyze this data that are really going to be very useful in future applications, especially working with other open data sets. And that goes double for code. You can learn a lot of these openly available code bases and learn to contribute to them. That often is really essential to working with open data as well. You also can use larger samples than most labs could collect, that an individual could collect. And that improves power, that improves reproducibility, all that great stuff. And I'll just point you towards a couple resources, one by colleague Corey, talking about a lot of different openly available data sets that one can use. And another is a computing resource, open computing resource called BrainLife. So if you are interested, please check those out. You might be interested as well with openly releasing data, code, and papers, because that improves dissemination. That means more people are aware of and can use your work. And that can also support your career, because for better or for worse, it's very important to make sure that you are recognized for your work, at least in academia. And the currency these days is citations. And we can have a whole conversation about that, but I just want to say, practically speaking, that is very important for an early career researcher to support their career. This also can lead to lots of collaborations, and I'll talk a little bit more about that in a bit. So I'll say from my perspective, I openly released this test-retest data set that I acquired, and that has, several people have reached out to me after that, finding it very interesting and wanting to use the data, and of course it's out there and they can use it. But I think that that's led to more attention for my work. I also have been privileged to be in a lab that values and has the privilege of being able to openly release publications. And I think that that has also been shown elsewhere to improve attention to work and citations, because if you reach a paywalled article and you might not have the time, you might be on your phone, or you might not have, you know, the access or through the university to read that paper, then you're not going to be able to understand and, you know, recognize that paper or cite it. Also, the effort that goes into openly releasing data and code tends to involve some level of awareness about making the data and code reusable, which means that that can also be reusable for you as well. And I'll refer you to FAIR principles that have been talked about elsewhere, perhaps in this session, but certainly in this conference, about the importance of making your data and code fair. You might also be interested in engaging in open collaboration. This really helps build your network, which is important for your career in many different ways. That can provide support and expertise in your work, or allow you to mentor others, give support. It can also lead to future collaborations as well. I'd like to also point out open collaboration is kind of a newer idea that's been integrated into open science, just this idea of, you know, collaborating more broadly than just in your individual lab. And open science platforms and groups tend to be a great way of fostering more open collaborations. So I'll reflect on a couple experiences that have occurred during the pandemic. There were a couple papers, one about inclusive conferencing, another one about brain hack. And I was able to provide feedback on the inclusive conferencing paper and a little bit of information, and help lead the brain hack paper. And that the brain hack paper in particular involved this massive group effort by a lot of people that really helped build my network. And I'm actually still in contact with a lot of these people. I've been since then working with several of those people in other initiatives, and in both in terms of like open science related initiatives and scientific initiatives. And I think that engaging in open collaborations can be a really, really exciting and important resource for ECRs. So if you see those sorts of opportunities that are open to anybody, I would urge you to jump in and get involved. Open science can also help you get funding and positions. It's not something that you usually think about as part of open science, but for instance, for grants, being able to save the time, the money, and the effort of collecting your own data really can support the feasibility of your grant, which is something you have to include in writing the grant. It can also help you inform your budget. You have to spend much less money on that grant. That also goes for like new faculty members. If you're able to use these open data sets, then you don't have to spend as much money acquiring your own data. And I'll also point out that hiring committees and organizations are increasingly considering your commitment to open science. This can be thought of as a commitment to service in the community, but also I know that Stanford, for instance, was hiring in the Wu Sci Institute, and part of the hiring information was to discuss your commitment to open science. And other committees, other organizations are also interested in your contributions as service to the community. And I'll point out there are also groups within OHBM, like the Open Science Special Interest Group, that specifically is interested in your commitment to open science. And I'm also part of that, and many others that are part of that group have also, you know, had a history of doing open science. So it can help you with all sorts of different types of positions and funding that you might not think about. So I'd also like to talk about how you might respond if your PI has specific kinds of concerns about your commitment to open science, or about what open science can do to contribute to the community. Just moving that out of the way so you can see the cartoon. So regarding open data and code, your PI might be concerned that it takes too much time to learn. And you can respond that it's much faster than learning how to and collecting your own new data. And that will also save time and money down the road when you want to use other open data sets. Your PI might not think you have the expertise in lab to provide training, but thankfully there are trainings available multiple times a year at other resources in the neuroimaging community, like at BrainHack and OHBM. And people in the open science community are really happy to continue helping. So regarding openly releasing data and code, the most common concern that you might encounter as an ECR is that you might get scooped. I want to say in practice, this tends to be quite uncommon, but if this is and you can tell your PI that, if this is a major concern, you can, somebody is working on a project and is already, close to, finishing that project, and you're really concerned because you're just starting. You could always wait until a later stage in your analysis or share once it's published. I just want to urge you to think about sharing at some point along the line, rather than just holding that data and code back forever, because that really supports future science. And also you can respond to your PI that will bring attention to your work. You or your PI might be concerned about people finding issues with your data and code. And I think that the most compelling response to that is really that you don't want bad work out there. If your PI doesn't find that compelling response, then you might have bigger problems. But I think that that's an important, that should be core to the way all of us do science. If you can't because of the institutional policy, there's not really a good workaround for that, but I would urge you to share what you can and be extra clear in your reporting so that people can try to reproduce what you've done as much as they can. Regarding open collaboration, your PI might feel it's a waste of time and doesn't benefit you, but you can definitely respond that you are networking and that benefits the lab, that brings positive attention to the lab, that makes the lab look good, and it benefits your career as well. And regarding getting funding, your PI might not think that people fund an open science project, and that might have been more so true in the past, but you can just look at the NIH Project Reporter, for instance, a US-based agency, and just see how many projects have used HCP data, ABC data, etc. There's definitely evidence. I said that my projects, my own projects have gotten funded and have used openly available data. And I think that there's clear evidence that times have changed and you can get funding with open science. So I'd like to touch upon really quickly a few special challenges for ECRs. Unfortunately, some best practices could disproportionately disadvantage ECRs. Open reviewing ECRs might be especially prone to retaliation for negative critiques. Restricting publication choices only to the journals that do the most stellar job of open science practices. Unfortunately, for better or for worse, ECRs are a little bit more vulnerable to being able to more broadly disseminate their work. So that can be a difficult choice or challenge for an ECR. I'd say if you're working with ECRs, it's important to be understanding about ways that they can be particularly disadvantaged by some of the choices, some of the best practices that you might want to engage in. And this goes double or triple or more so from ECRs from underrepresented groups in science. Open science should be inclusive science. Unfortunately, a lot of open science can feel very exclusive. There's this term bropen science that have been coined by a few members of the community. I would just be especially aware of that. If you come from an underrepresented group, there are a number of communities that you can be involved in, and the open science communities here at OHBM are particularly supportive and interested in supporting underrepresented groups. So please reach out and please be aware that some of these practices can disproportionately affect you. And finally, I'd like to end by saying it's important to be strategic. You can align your goals with your PIs and really try to avoid getting burnt out or doing things that might harm your career as an ECR. If you give back 100% to the community, but for instance, you're not able to disseminate your own role in the work, that's not, unfortunately, that can sometimes be harmful in academia. So just be aware of this balance that can be struck in the earlier career side. And hopefully when you're a more established researcher and you have secure funding and tenure, you can go ahead and pull out all the stops. But until then, just be very careful. Try to do the best that you can, but try to be protective as well. All right, thank you.
Thank you very much, Stephanie, and get well soon. We have still time for a couple of questions for our speakers here. If you have any question for Stephanie or for Priya, please write it in the app with @Priya or @Stephanie. And when they will get better or they will wake up, they will answer to you there. You can also ask questions on ohbm.cnf.io if you want to add something and you don't have the app with you. All right, we have to choose a very good questions because we don't have much time. Let's say something that can cover both of you and is about open science. How can we promote open science and open science practices when our superiors, our bosses, our supervisors, our professors are not open scientists or are not open scientists thinking forward? And how can we implement a better open science environment around us when we are in a model that it's publish or perish?
I've got that. So one way you can go about it is a bit of a mantra that I apply sometimes, which is it's better to ask forgiveness than seek permission. So sometimes what is it within your power to actually do? Kind of like what can you get away with? And seek forgiveness afterwards. That there's certain practices that you absolutely you should not do without your PI's approval, like pre-registration, or maybe publishing your code because there are implications around licensing. But even something like a preprint that I think is very low risk. And it's about familiarizing people with the safety of these things. I think that's a big turn-off for a lot of people. They're scared because it's different and it's not how they've played the game. But also they think they're exposing themselves to certain risks, like Benjamin said. So it's about slowly encouraging them, making them feel safe. But also, I think, know that it is the way the community's moving, and one resistant PI will ultimately, I think, become in the minority. You'll be in more places that are more encouraging about it. So show them that other people are doing it and that it's not scary and it's not going to be damaging for their career.
Benjamin, do you want to add something?
I can add to that a little bit. Open science is not a full science that has evolved and is mature. I think it's still evolving, so we need to be aware of that. If you're just starting with open science in your lab as a PI or as a student or wherever you are in the lab, well, and if you don't know what to do and how to convince people to do it, well, go elsewhere and ask questions, because people are doing the same thing at the same time as you, and maybe they are a step further. So I think a good way of promoting science and making sure that you don't encounter a lot of resistance is just asking other labs that have done a little bit of it. Maybe they're full open, probably not, and then just ask them to come over and then talk about their experience. And that's, I think, the best way to convince people to embrace the open science way. And I think that's the way the community is going. So there's definitely some people that you can ask.
Yeah, and while we're sort of still in the minority, I think just it's really important to connect with other people that are doing it. Join communities, go to hackathons, hang out in places where open scientists hang out, and find the people that can support you on your journey, because the more comfortable you are, the easier it will be for you to convince other people.
Okay, thank you very much. We have time for one very last question. That I lost. Okay, it's here. What do you think about, what do you think on the push for researchers to be full stack skilled? And on the other side, what do you think would be the best practice to have TIRRs in your community, in your department? How can you push for it, both from one perspective and the PI perspective?
I didn't get the question, I'm sorry.
Sorry. So what do you think about scientists being full stack skilled on one side, and on the other, how do you think, like what would be the best practice from you as a PI and from you as a TIR to
I truly believe that no one can be completely full stack. That's impossible. You have, if you really want to be full stack, you have to do everything, like research, like back-end development, software application, documentation. You have to know everything. Even as a PI, we tend to say PIs know everything. We know nothing. We rely on people to tell us stuff. So I don't believe a full stack person ever exists, like a real, true full stack person. So we have to diversify. And that's the challenge. We have to find the right person for the right task. And that's really the challenge. If we could find someone that knows it all, maybe they exist a little bit, that would be awesome. But I don't think that exists, and you should not pursue it. Like having this one person that you rely completely on, and then you put so much pressure on it. You should not do that. So I truly believe that you need to have a diversified set of persons with different skills. And what we try to do actually in our lab is we have multiple PIs and we share these persons because you cannot have, you don't have the resources to have one person web developments for your own research. That's too much, right? And so, but if you share this person through different projects, that's a good way of having this person on board.
Yeah, so there's some really interesting literature on this, and the tension is between the classical researcher or like ivory tower kind of person who is responsible for every part of their project, and what they see the diversification of roles as being like this kind of neoliberal like ugliness, like you're trying to take the power away from me to do everything, control everything around my research, and you're trying to spread it out, and you're just trying to create money and jobs and stuff like that. So there's some kind of conceptual tension in the academy. Like some people like us are really up for the diversification because it means people can specialize and be wonderful. But I think it's the kind of the old school idea that you should be able to do everything. Like, oh my gosh, trying to do everything in your PhD is like damaging. And you end up doing try to do everything, but you end up doing a lot of things badly. And I think we should reduce the expectation that people should be able to do everything. I think it's important to be able to try everything to find out what you really want to do, but there shouldn't be pressure other than to try and to develop skills in ways that interest you.
I think we can thank you, the speakers, once again for their topics and the talks and the questions and the answers. And thank you very much for attending this talk and this symposium, and thank you very much for your questions. I am very sorry that we couldn't ask all of them. They were very good, all of them, and I would invite the speakers to have a look at the app and answer to them through the app itself. For the rest, if you don't know it, we are going to probably be hanging out in the room upstairs. There's a room called Open Science Room. It's marked as Gala. It's really literally upstairs here. Please come by and check out our schedule. There's a lot of fantastic open science related and career related development talks and topics and discussions. So I hope to see you there. For the rest, have a good day.
And also, the Open Science Group, we are going to open the application for our group soon. So if you want to join us, if you want to learn about open science, if you want to contribute, then keep your eyes peeled for tweets and announcements. Thank you.